Hello, dear students. In the previous lecture, we studied some basic concepts which are related to photoelectric effect and what are the various factors that govern work function. So, work function is, as we know, the minimum amount of energy that is to be supplied so that the electrons will get ejected from the material, a metal surface. So there we were concerned with the free electrons. The free electrons are to be ejected from the material because free electrons are very loosely bound to the nucleus. So, dear students, now moving further, we have to study that is photoelectric effect and what are the various factors which govern photoelectric effect. So, when the emission of electrons was done by temperature difference that we call as thermionic emission, and if it was done by some field electrostatic potential we call that as field emission, and if that was done by some collision we call that as secondary emission, and if the emission of the electron from the metallic surface was done by photons, that is what we call as photoelectric emission or photoelectric effect. So photoelectric effect is nothing but emission of electrons from the surface of metal, from the surface of metal using a certain energy, because we had to provide some energy. Now moving further, we had to study what are the various factors that govern it. Firstly, dear students, do remember that this photoelectric effect was studied by Hertz. Not going into the detail of the same as this is not in our syllabus. What was, just giving you a brief idea about Hertz. Hertz was studying the production of, while studying the production of EM waves, that's electromagnetic waves, by spark discharge. By spark discharge. There he noticed some enhancement when the detector was illuminated by ultraviolet radiations. There he enhanced observed some enhancement. There he concluded that when a light of suitable frequency falls on the metallic surface, electrons get ejected from it. Now after that there was Helvach's experiment. They gave the concept about the threshold frequency. So in the previous lecture we discussed about work function. In work function we were concerned with, that is denoted by phi naught, we were concerned with energy. Now in the concept of threshold frequency, it is same or similar to that of work function, but here we are concerned with the frequency. That is what we call as the minimum frequency that we are supposed to have so that a metal may lose its electron when that light or radiation of that frequency is allowed to fall on that metallic surface. So dear students, suppose if we have a metal and I am using a radiation, both of having energy, or this metal needs, or this metal has work function of 2 electron volt. So what does that mean? That the minimum energy that I have to apply so that the electrons will get ejected from the surface of the metal, that energy is known as work function. But the minimum amount of frequency that I have to apply, that the wave must possess, or radiation must possess so that it can knock down the electron will be known as threshold frequency. So threshold frequency is same to that of work function, but concern is with frequency. Minimum or amount of frequency we denote with V, nu actually, so that the electrons will get knocked out. So for photoelectric effect, now studying the experimental setup of photoelectric effect, what we do actually? Here we do place two plates like this, and this plate is known as, we call as emitter. By emitter what we mean that it will emit electrons, and this plate we call as collector. By collector what we mean that it will collect the electrons. Okay, here we will use a transparent, this, if I will change its color, this frame, this hole will be transparent. See dear students, experimental setup is very easy. Then we have to understand the concepts that if we will change the frequency, we will change the potential, what will happen. This is connected to somewhere with micro ammeter. When the light of suitable frequency falls on this emitter plate, this emitter plate is maintained as at negative potential. At negative potential, electrons for obvious will get ejected from it, and this is maintained at positive potential. This is maintained at positive potential. Electrons being negatively charged, when they will get knocked from this emitter plate, will move towards collector plate. They will keep on moving towards collector plate. When these electrons, serious students, these electrons which are ejected or from the emitter plate are ejected by the means for the same is photons. So these electrons will be called as photoelectrons. And how will we know that the electrons are ejected and they have reached the collector plate? That will be guided by microammeter. It will show some slight deflection. If there will be deflection in it, so which will infer that there is movement of electrons towards the collector plate. Okay. Now, if this collector plate, which is at positive potential, if it is now kept at zero potential. So dear students, it was very clear to you, firstly, when the light of suitable frequency, that is threshold frequency, is supposed to be there, because beyond threshold frequency, the photoelectrons will not get ejected. That is the primary criteria, and this was even asked in one of the competitive exams. So when this light of suitable frequency falls on this emitter plate, what will happen? The electrons will get ejected and they will move towards positive plate. If I will increase the positive potential of this collector plate, the electrons will keep on moving towards positive potential, that is collector plate. But the moment I maintain the zero potential of this collector plate, what will happen? The electrons which are getting emitted from the collector plate will not be able to reach the collector plate. They will remain somewhere in between. They will remain somewhere in between A and B, like if I will write it as A and if I will write it as B, they will remain somewhere here. So these electrons will get accumulated in between emitter and collector plate. We will call this as space charge. So dear students, at space charge, what actually happens? When the potential of this is zero, no electron is able to reach it, that is collector plate, and the charge or the electrons get accumulated in between A and B. That is what we call a space charge. At space charge, the electric current is minimum. Very important thing. Even being asked, this question was also asked that at space charge, what is the value of photoelectric current? Do remember that it is minimum, not maximum. And at space charge, now if I will sum up from the exam point of view, at space charge, the potential at B is zero, and I will denote it, photoelectric current is minimum. Okay, dear students. So is this clear? The light from sunlight comes, the light of suitable radiation frequency comes from and it falls on the emitter plate, it reaches to the collector plate because of having opposite potential. Then accordingly, if we maintain the zero potential of this, the electrons will not be able to reach the collector plate, and the electrons, that is photoelectrons, will get accumulated somewhere in between these two, that is what we call a space charge. Now, if I will ask you, dear students, this was actually the experimental setup for the photoelectric effect. Here were inferred many things, that is, on what factors photoelectric current depends. It firstly depends on many things. Let me write the factors. First is intensity of the radiation. Second is, because intensity is what we denoted P by A, that's power by area, that's actually denotes a kind of energy. And second thing is potential difference. As you noticed, if the potential difference is changed, accordingly photoelectric current change. Potential difference between the plates. Plates, by plates, what I mean, dear? Between emitter plate and collector plate. A and B, if I will denote them. A and B. Third is frequency of incident radiation. And the fourth one, on which the photoelectric current depends, which we are concerned with, is nature of material. In the previous lecture, I have told you that how the photoelectric effect depends, actually the work function depends on the nature of the material by discussing the electropositive and electronegative concept. So now we will discuss first intensity. Then after we will discuss each and every part separately. Now discussing the effect of intensity. Discussing the effect of intensity on photoelectric effect. Effect of intensity on photoelectric effect. This is very important from the exam point of view, and this has been asked many a times. Dear students, you observe that if the light of suitable frequency is falling and it is falling on the emitter plate, the photoelectrons get emitted and they reach the collector plate. Okay, this will keep on going. Now, if I will keeping the potential of the collector plate positive as it was, if I will keep the electrostatic potential or electric potential at collector plate constant, I will not change it. Then on how can I change the photoelectric current? The first thing, that is what I have to do, is keeping the potential at collector plate constant, I will increase the intensity. Increase the intensity. So if it is being asked what is the effect of intensity on the photoelectric current or photoelectric effect or photoelectric current emission, if we keep the potential of the collector plate positive as constant, we will not change its magnitude. But if I have to change the photoelectric current, I need to increase the intensity of the photoelectric current. I will increase the photoelectric current, intensity of the photoelectric current, then accordingly photoelectric current. Increase the intensity of radiation. Sorry. Increase the intensity of the incident radiation. When I will increase its intensity, what will happen? Accordingly, it will change. Now, notice one thing. This graph is to be this is photoelectric current, this is intensity. When the intensity of the radiation keeping the positive potential of the collector plate constant, which we will change in the next effect, what was observed that as the intensity is getting increased, the photoelectric current increases linearly. So I can say, if this is being asked to you, what is the relationship between photoelectric current? Photoelectric current, if I will denote it by Pi, that is directly proportional to intensity of light. This is very important. So I can say the number of photoelectrons. So I can say number of photoelectrons emitted per second, emitted per unit time or per second, because current is charged per unit time. That is the reason we have to deal with the rate of the flow of electrons. Emitted per second or per unit time is directly proportional to intensity of the intensity of incident radiation. This is very important, dear students, that how the intensity of the incident radiation affects photoelectric current. So number of photoelectrons, as the number of photoelectrons will increase, we know I is charge divided by time, and I is equal to n E divided by T. If n will increase, I will accordingly increase. As we know, intensity will get increasing, the photoelectric current will keep on increasing, and there is a linear relationship between them. So dear students, I think this is clear to you that what is the effect of intensity on photoelectric current. Now the second effect we have to deal with is second effect of potential difference, or I can say effect of electrostatic potential of the collector plate. Now dear students, visualize one thing again. This was our what we call as emitter plate. This was our collector plate, which was connected to microammeter just to confirm the flow of electrons. Electrons were moving from this direction to this direction as they were getting emitted from this. Sorry. Light of incident suitable frequency falls on the emitter plate and they will reach the collector plate accordingly. If the positive potential of this collector plate is increased, what will happen? More and more electrons will be drained. If potential of C, I will denote it as E or AB whatsoever, as it is collector I will denote it with C. If the potential of C is increased, more and more electrons will move towards the collector plate, then that means we will get maximum current. As we know, Ne upon T. I is equal to Q by T. Q is Ne by quantization of charge. Here, as the number of electrons will increase per unit time, then accordingly current will increase. If potential of C, that is positive potential of collector plate, is increased, we know photoelectric current will also increase, dear students. And if I will increase it to maximum level, if I will further increase, after increasing to a certain level, a maximum value reaches. At maximum value, this photoelectric current, or I can say a value will come which will be maximum, at which if I will further increase the positive potential of C, if VC is further increased, there will be no increase in the photoelectric current. So that, what does that mean? The maximum value of current which I will get, maximum value of current which I will get by increasing positive potential. After that, there will be no increase in the current, maximum value of current. That current is known as saturation current. Saturation current. So if saturation current is being asked to you, what will you say? That it is the maximum current beyond which if which is attained when the potential, that is positive potential of the collector plate is increased. After that, if we'll further increase the positive potential, that can be increased if that is further increased, but there is no increase in the value of photoelectric current, that current is known as saturation current. That means this has reached to a maximum value. This current has reached to a maximum value. That is the reason we call it as saturation current. Now, dear students, you have observed that at saturation current, that is having the maximum value, current at saturation, or I can say the maximum VC or the maximum positive potential, it is having current is having maximum value. Now, what will I do? I will do reverse of it. Here I was increasing its positive potential. Here I was increasing the positive potential. Now, if I will decrease the positive potential, what will happen? That means I will make it negative. If I will decrease its positive potential, what will happen? Electrons will try to move. But as there is repulsion between, as it is at negative potential now, there will be repulsion of electrons. When there will be repulsion of electrons, as this collector plate was connected to a microammeter, will there be any deflection? No, there will be no deflection. If I will increase the negative potential of collector plate to such a limit where the current will become zero. Why the current will become zero? This is to be understood. When it will be having negative potential, maximum highest negative potential, the electrons will be strongly repelled by this negative plate, and the electrons will not be able to move towards this positive plate. Even the fast moving electrons cannot also reach the collector plate. So that maximum negative value, because I am increasing it by negatively, because electrons will get repelled only by negative potential. So can I say the maximum negative value of voltage or potential difference where current becomes zero or photoelectric current becomes zero is known as cutoff potential, cutoff potential or stopping voltage. Cutoff voltage, stopping potential, you understood that is the maximum negative value, because I was increasing the negative value for C and it was repelling the electrons were not able to reach there, then the current becomes zero. So we understood two things. One is saturation current, and the other is cutoff potential, cutoff potential or stopping voltage. So dear students, if I will observe one thing, if I will now draw a graph, let's draw it very correctly. Okay. Uh, okay, dear students. Okay. Here we do have photoelectric current. Here we do have voltage, or I may say potential difference. And for your basics, you might be knowing, if we talk about abscissa and ordinate, at every position of y-axis, x is 0. And at every point of x-axis, y is 0. If I will ask you what will be the value of photoelectric current over here? You will say, sir, 0. Because on our ordinate, on x-axis, I may say, the photoelectric current will be 0. And if I will ask you what will be the value of voltage over here or potential difference here, you will say that it is 0, because on y-axis value of x-axis is also 0. Now, I was having some current I1. What does mean by the current I1? I was using a light of certain frequency or certain intensity, and I got a current I1. We know intensity of light is directly proportional to, or photoelectric current is directly proportional to intensity. Now, if I will increase the intensity, current will be I2. I'm just assuming this. You cannot say this will be, there will be a linear line between these two like this. This is not possible, because here we are plotting a graph between photoelectric current and voltage. So we cannot take it like this. If I will use one more, if I will increase the intensity, for obvious the current will increase. Why I am writing I1 over here, I2 here and I3 here? Because these are the corresponding values. So for obvious I3 will be greater than I2, I2 will be lesser than I3, and accordingly. So dear students, now plotting graph, what is the relationship of saturation current? Here it assuming that at particular intensity the current has reached the maximum value, that is what we call a saturation current. If I will reduce the voltage, as I was doing it, I was increasing the negative potential of, I had to increase the negative potential. So here it is positive potential, here it is negative potential. I am increasing the negative potential. What will happen? The current will reduce or accordingly. And why I am making the graph towards the negative part? Because we know at negative potential only current will be 0. So dear students, you cannot take it like this. You can say, sir, here also voltage is 0. At voltage is 0. Yes, even though voltage is over 0, but we do have a positive voltage over here. Here current will not be 0. Here current will not be 0, because the electrons, positive voltage means that there is a positive potential at capacitor collector plate A. So the electrons will be there and there will be current, and we cannot take it at over here. Okay, dear students, so I have to take it to such a point where it represents the negative potential. Similarly, if I will increase the negative potential, even increasing the negative potential, electrons will get repelled. When the electrons will get repelled, there will be no photoelectric current. So they will reach a particular value. Just with the drawing, dear students. So this value at which photoelectric current is 0 is, dear students, what we call as cutoff potential, and I can't note it here. So is this clear to you, dear students, how increasing the negative potential makes, how this graph is made, and by increasing the negative potential how the current gets reduced from saturation level, it reaches to 0 at, or I can say this point we call as cutoff potential or stopping potential. Stopping potential. So in this video we understood a few things. The first thing was, what is the effect, what is photoelectric effect, emission, work function, we already discussed in the previous video, threshold frequency. Then after we studied uh, the experimental setup, right? This is been asked, this can be asked like this: what is the experimental setup? Experimental setup you have to deal with. Like this radiation was coming over here on emitter plate. Emitter plate what was at negative potential, that is, it was full of electrons kind of. It will emit electrons, they will reach the collector plate. After reaching the collector plate, that collector plate is connected to microammeter, which will confirm us whether there is photoelectric current or not. Then if I will make this collector plate at 0 potential, what will happen? There will be electrons will get stuck in between A and B. That is what we call a space charge. At space charge, I told you that at space charge, this is being asked that potential at B will be 0 and the photoelectric current will be minimum. Then after we studied what are the various factors affecting If this will be asked to you, you can write it like this: factors affecting photoelectric effect. Factors affecting photoelectric effect. Dear students. Photoelectric effect. What are the various factors which affect photoelectric effect? First is intensity. We know we will discuss it later on, and the potential difference, frequency, and nature of material. Here we discussed only two things, that is effect of intensity of the photoelectric effect. If it will increase, it will increase. If there is any confusion, you can rewatch the video so that you can get. Here we inferred that the potential difference is directly proportional to the intensity or number of photoelectric current is directly proportional to the intensity of the intensity of the radiation, incident radiation is directly proportional. How we draw this graph, this was very clear to you. Then after we studied the effect of potential, there we studied saturation current, which is the maximum value of the current, which upon increasing the positive potential. Do remember, in saturation current, we increase the positive potential of collector plate. Okay. Then we will increase the negative potential. There we get a zero current. When the photoelectric current becomes zero, that is what we call as cutoff potential. So then we understood how this graph is drawn and what factors, why we have taken this point as the cutoff potential, because we have to increase the negative voltage, so I cannot take it here. So this was all about two important aspects, that is on what things the photoelectric current depends.